All right, guys, let's make sure you're ready for test 5. Test is on Thursday. I'm going to go through each of the questions on the review. In case you get stuck, you don't have to use the get help button. You can go ahead and look at them here. So this is number 1. Number 1 wants us to fill in the statements for this proof. And it starts by saying that C is the midpoint of AD, which is our first statement here. Now, remember, with proofs, you're trying to match the statement with the reason that that is true. In this case, this is true because that's what it tells us. That's the given. So number 1 right there would just be given. So we know that C is the midpoint, which means it's in the middle. Statement 2 says that AC, which is this part right here, is equal to CD, which is this part. And we know that that is true because C is the midpoint. That's what makes those two equal. So my answer there would be that's because the definition of a midpoint. Remember, the definition of a midpoint tells you that the two sides are equal. Step 3, it does it for you. It just says that if those are the same length, then they're equal to each other. Step 4, we go from AC equals CD to 7x equals 3x plus 8. So what they did there is they took these segments and they substituted the values in. So that uses substitution. That should be an easy one because they went from letters to numbers. So you should know that they must have substituted something in. Step 5 wants us to use the subtraction property. And if I look at number 4, I'm at 7x equals 3x plus 8. It wants me to subtract something from both sides. Well, I could subtract the 8, but then I'm going to end up with 7x minus 8 equals 3x. That doesn't help me. I want to subtract 3x from both sides. And when I do, I get 4x equals 8. So for step 5 right here, I'm going to choose 4x equals 8. And then to get from step 5 to step 6, we got rid of the 4 by dividing by 4. So that would be the division property. So step 1 should be a no-brainer. I think the only one that takes a little bit of thinking is step 2 right here, definition of midpoint. But again, if you've practiced a little bit, we know that if C's in the middle, we know the sides are the same. So that should be a pretty easy one. Number 2. Use the symmetric property of congruence. Now, when you get to this one, it might ask you to use the symmetric property, or it might ask you to show something using the transitive property or the reflexive property. So make sure you understand symmetric, transitive, and reflexive, because this question is going to ask you about one of those. In my case, my example wants to use the symmetric property. So if JH is congruent to UV, then what is congruent to JH? Well, that's easy. UV is congruent to JH. Remember, symmetric property just flips. That's like saying A equals B, so B equals A. Reflexive, that just means that A equals A. That's the reflexive property. And the transitive, in case you forgot that one, is where we say A is equal to B and B is equal to C. So if A is B and B is C, then we know that A is equal to C. So make sure you understand all 3 of those. All right, number 3, another proof. This one's a little bit easier because it's just algebraic. It gives you a statement, 2 times x minus 3 equals negative 19. And then how do I go from this step to the next one? I use the distributive property. I know that I use the distributive property because if I was solving this problem, I would distribute. So I distribute, and then I get 2x minus 6 equals negative 19. To go from here to the next step, I've got a minus 6, and the opposite of minusing 6 is to add 6 to both sides. So they used the additive property of equality. And then to go from 2x minus 13 to get rid of that 2, we had to use the division property. So make sure you understand which property does what. Again, these ones are easy because you know what the distribution property looks like. you know how to if you have a -6, you know how to move it to the other side. We just add 6 to both sides. That's how we know it's the additive property, because it's just what we did mathematically. All right, number 4, use the substitution property to complete the statement. So it tells us that ty is equal to 5. And then it says that BC plus ty is equal to OP. And it wants us to fill in the blank. So what else is equal to OP? Well, if I know that ty equals 5, instead of this ty, I'm going to plug the 5 in right there. So I'm going to plug it in and get BC plus 5 is equal to OP. And I think it even gives you a drop-down menu. So you don't even have to type that in. You just have to recognize which one is the correct one. Okay, number 5. Identify the pair of same side interior angles. So in the example, you need to know what same side interior angles are. But this question could also ask you to identify corresponding angles. It could also ask you to identify alternate exterior angles or alternate interior angles. So make sure you understand all 4. Don't just memorize this one, same side interior. You need to understand all 4. So same side interior means they're on the inside and they're on the same side. So there shouldn't be any lines in between them. So if I look at 5 and 6, here's 6, here's 5. Those are made up by D and E crossing. Whoa, that's a bad highlight. Let's make this a little bit smaller. So those are made up because D and B make up angle 6, and then E and B make up angle 5. So they're both inside, which satisfies the interior part, and they're on the same side of B, which satisfies the same part. So I'm thinking that 5 and 6 is the right answer. But just to make sure, let's look at 6 and 8. 6 is right here. 8 is on the outside. So they're on the outside, not the inside. And they're on opposite sides. They alternate. So it's definitely not C. 1 and 4. 1 is on the inside. 4 is on the inside. Definitely not those, because they alternate sides. They're not on the same side of the interior. If this said 1 and 7, we could say that those were the same, but it doesn't. And then 6 and 7. 7's right here. 6 is here. They're both on the same side, but one of them is in, one of them is out. So they aren't both interior angles. Now, what I think makes this problem a little bit more difficult is it wants you to identify the 2 lines that make up the transversal. So for me, I want to look at what lines make up angle 6 first. Angle 6 is made up by this line and this line right here. And angle 5 is made up by this line and this line. So this one is angle E. This one is angle D. And the one that goes up and down is B. So my answer is going to be D and E with the transversal equaling B. I'm looking for the answer that has those 3 in it together. All right, number 6. Find the value of X so that these 2 lines, M and N, are parallel. Well, if M and N are parallel, then these 2 angles are alternate exterior angles, which means they should be equal to each other. This angle and this angle are both equal to the same thing. So I know that 3x minus 39 is equal to 2x plus 12. Now I just need to find x. So let's add 39 to both sides. So 3x equals 2x plus 51. And if I minus 2x from both sides, x equals 51. And that's what it wanted. Find the value of x. So I'm done. Number 7. Find the value of x that makes m and n parallel. So again, we want these to be parallel to each other. But when I look at these two angles, this one is outside, this one is inside, but they're on alternate sides of my transversal right here, which means we don't really know anything about those two angles compared to each other. So we have to do a little bit of work. If this is 92 degrees, just looking at my picture, I know that these two angles add up to 180. So if I add this angle, I should get 180, which means this angle is 88 degrees. And the good thing about that is now I know this is 88 degrees and this is 3x minus 17. These are alternate interior angles. And we know that alternate interior angles are equal to each other. So I know that 88 is equal to 3x minus 17. So all I have to do is add 17 to both sides. So 105 equals 3x, divide by 3. 35 equals x. Okay, there's other ways to solve this one. We did it differently in class, and now here's an alternate way to solve it. Okay, all right, number 8. On the homework, this one gave everybody a little bit of grief, and just plan on the review and the test. These numbers might not be in the same place. But when I look at the picture, it wants me to figure out x and y. And I know that looking at my picture, x and y right here, these two make a straight line, which means that x plus y add up to a straight line, which is 180 degrees. The problem is I don't know what x is and I don't know what y is. So I can't figure out the other one. So let's look at this angle right here, 29y. And if I'm looking at my picture, I've got a line right here that comes down. And it gives me a hint with these red arrows that I've got two parallel lines, which means that 29y and x are same side of the transversal, but one is outside the parallel lines and one is inside, which means that these two are what we call, if you remember, corresponding angles, which means they're equal. So x is equal to 29y. And what's nice about that is now that I know what x is, I can plug it in. 29y plus y equals 180. I just took this value and plugged it in for x. And 29y's plus a y is 30y equals 180. And when I divide by 30, y equals 6. So if I know that y is now 6, that's part of my answer, but I also need to figure out x. Well, these still add up to 180, but this is 6. So what plus 6 equals 180? Well, that's easy. That's 174. So x is 174 degrees. All right, number 9. Complete the proof. IE is congruent to GH. So it tells me that this line right here is congruent, the same as this line. And EF is congruent to FH. So these two are congruent to each other. And F is the midpoint. So this right here is the middle of these two pieces. So the first statement that it tells me, IE is congruent and EF is congruent. Well, that's all given. So reason number 1, I'm going to say that that's given information. And then it's going to tell you something like this. It's going to tell you that GF is congruent to IF. So it's telling me that this line right here is congruent to this line, and it wants me to give a reason. Well, the reason is F is the midpoint, which makes these two the same distance. So for my reason number 2, I can put definition of midpoint. And step 3 is an easy one because I know that one side, two sides, three sides are the same, which means that the triangles are congruent And the reason they're congruent is I know a side, and a side are the same. So side, side, side proves that those two triangles are the same. Okay, number 10. A fluff question. Would you use side, side, side or side, angle, side? Well, just look at the picture. It gives me a side, and then it gives me an angle, and then it gives me another side. Well, which one is that? Side, angle, side. So it's not side, side, side. Duh. It's going to be side, angle, side, because those are the pieces that it gave me. All right, number 11. This is one of my favorite questions on the test. Actually, it might be my favorite question on the test because it gives you this picture that looks like one big triangle. But to solve it, we actually need to look at the two little triangles. And the first triangle I'm going to look at is this one right here, because I need to figure out M. And to figure out M, I know that this square means this is 90 degrees. But I don't know this angle. I can figure it out because I do know that this angle and 138 together make 180 degrees. So 138 plus this angle equals 180, which means this angle, if I just subtract 138, that means this angle is 42 degrees. So if I know these two angles, 90 and 42, those add up to 132, which means my third angle of the triangle has to make it add up to 180, which means that I just have to do 180 minus 132, and I get that this is 48. So M is 48 degrees. Okay. Now it wants me to find N. So it's going to also ask you for N. And to figure out N, I'm going to ignore this whole part of the picture for a minute. And I'm just going to look at this triangle. It gives me some cool information. It tells me that these two sides of the triangle are the same, which also means that if two of the sides are the same, then if this side is N, this side is also N. So these two angles are actually equal to each other because it's an isosceles triangle. So I have two angles that are equal. I also know that the angles of a triangle add up to 180. So if this angle is 138, then these two angles have to add up to 42, which means when I divide that in half, one of them is 21 and the other one is 21. So N equals 21 degrees would be my answer. Great problem. It may not give you these two same triangles. In fact, I've seen one where you had an isosceles triangle like that, but connected to it was an equilateral triangle. So it would be good to remember if all three sides are the same, then all three angles are also the same. Okay, number 12. Another proof, it tells us that V and Y are the same. So angle V right here and angle Y, we know those are the same because it's given. And WZ bisects VWY. So this line right here cuts this angle W in half, which means that this angle and this angle are going to end up being the same. So number one, WZ bisects VWY. That's given. Then it says that VWZ, let me erase some of this because I'm working ahead a little bit. It tells me that VWZ, which is this angle right here, is the same as YWZ. So it tells me that these two angles are the same. And the reason I know that's the same is because this line cut the big angle in half. That's the definition of a bisector, of an angle bisector. It cuts the angle in half, so these two are the same. So I know that they're the same. And then V and Y are equal to each other because that's given. And then WZ is congruent to WZ. So this line in the middle is congruent to itself because of the reflexive property. Remember, reflexive property says that A is equal to A, 7 is equal to 7, WZ is equal to WZ. So that's how we know those are congruent. So the last one, how do we know that these triangles are congruent? We either need side, 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 angle, side, angle, side, angle, or angle, angle, side. Well, I have an angle right here. I have an angle right here, and then I have a side. So I'm going to choose angle, angle, side because they go in that order. Okay, 13. Determine which one of these is true. The point of concurrency of the angle bisectors. So if I have a triangle and I want the points where the angle bisectors cross. So if I cut all the angles in half, it wants to know what is that point. Well, in your notes, you should have it written down. The angle bisectors cross to make the incenter. So this would be the incenter of the triangle. That's the point of concurrency. Easy problem. 14. A little bit more complicated because we have to look at the picture and it wants us to figure out what point P is. So I have to figure out, is this the incenter? Is it the circumcenter? Is it the orthocenter? Or is it the centroid? Well, I've got these lines connecting the corners, but the only one of these that uses the angles is my incenter. But when it does that, it cuts the angles in half, and there's nothing to tell me that the angles are in half. So I'm not going to use that one. But I do know, looking at the picture, I do know that this line and this line mean that this piece right here, EB, is the same as AE. So that means that E is a midpoint. And I also know that these two pieces are the same. So that means that D is a midpoint and F is a midpoint. Well, the circumcenter uses the midpoint. The orthocenter and the circumcenter and the orthocenter and our incenter doesn't use it. And then our other one was the centroid. So which one of those connect the middles? The centroid uses the middle, but so does the circumcenter. But the orthocenter has nothing to do with the midpoint. So I know it's one of these two. Well, I also know that these lines are perpendicular. The centroid is the lines that go from the middle to the corners. But these points go from the middle. They don't go to the corners. They go perpendicular. So I know that it's the circumcenter. So P is the circumcenter because these lines are perpendicular and they go through the midpoints. And what's cool about the circumcenter, if you remember, is the distance from the circumcenter to each of the corners is the same. So if this distance is 27, then this is also 27 and this is also 27, which means that PA from P to A is 27 units. So that's number 14. Yours may not be a circumcenter. You've got to look at the picture and figure out what it's using. Okay, so 15. It tells me that P is the centroid. So I know I'm dealing with the centroid. And if you remember, the centroid, one of the special things about it is the distance from A to P is double the distance from P to F. This length right here is double this length. So it wants me to find PD right here. Well, I know that PD is half of this distance because this is double PD. So if this is 40, then PD is just 20. That's it. If it had given me, let's say it gave me PF and it told me PF is 5, well, because this is the centroid, I would know this is 5, so this is 10. Or if it told me that CP is 30, I know that the rest of that line is half as long, so that would only be 15. Okay, 16. I like this question because it's a little bit challenging. It tells me that I have a triangle and G is the in-center, which in this case doesn't really matter that much, but it tells me that EFD. So EFD, this angle right here, I'm just going to make this, I'm going to call that F because it's EFD. So really that's just angle F. F is 60 degrees. And then it tells me that EDF, so from E to D to F, so that's, let's just change that to angle D. Angle D is double DEF, which is angle E. So angle D, this one, is double whatever E is. I don't know what E is, so I'm going to call it X. And I don't know what D is other than it's double. So I'm going to call that 2X. And that's all the information it gives me. And it wants me to figure out what these two angles are. Well, I know the angles of a triangle. If I add all three of those together, I get 180 degrees. 2x plus x is 3x plus 60 equals 180. So if I minus 60, 3x equals 120. And if I divide by 3, x equals 40. So this angle right here, angle DEF, this x is 40 degrees. So DEF is 40 degrees. And since this one is double that, that angle is 80 degrees. And you're done. Okay, so that's the test. Practice these problems. I know I just went through them with you, but try and do each of these problems on your own without help from me or YouTube or anything else. Take good notes and just make sure you understand how each of these problems work, and you'll be more than prepared for the test. All right, good luck.